So we've talked about the magnetic field, but we have yet to define it. We've talked about it in amorphous terms. We're now actually going to define it in specific terms, which is that the magnetic field or what's called the B field, the symbol we use for a magnetic field is a capital B. The magnetic field or B field is defined by the fact that a moving charge, bless you, can experience a magnetic force. And the symbol we use for the magnetic force is F sub capital B. So a magnetic field, which is a capital B field, that's how we draw it, is defined by the fact that a moving charge can experience a magnetic force, and we call that F sub B. The equation that we use to determine the magnetic force is the magnetic force equals Q V B sine theta, where Q is the charge, V is the velocity of the charge, B is the magnetic field, and theta. Just like all the other equations we've worked with that have this theta, for example, work and power, for example, this angle has always been the angle between the vectors in the equation. So there are three variables that could be vectors, Q, V, or B. One of them is a scalar. Which one, charge, velocity, or magnetic field, is a scalar? Dana? Charge. So the theta is the angle between the velocity and the magnetic field. Now, this equation gives you the magnitude only. We'll talk about the direction in just a little bit. I'm going to do a little bit of other stuff first. But this equation gives you the magnitude of the magnetic force. We need to figure out the dimensions for the magnetic force. In order to do so, we're going to solve for the magnetic field in this equation. It's equal to the magnetic force divided by the charge times the velocity times the sine of theta. So let's get dimensions for this. Wicket, the magnetic force. What are the dimensions on force? Newtons divided by the dimension for charge. Coulombs multiplied by the dimension for velocity. Times the dimension you get when you take the sine of an angle, for example, sine of 30 degrees, sine of pi radians. You actually don't get degrees. There's a reason she's confused. She's looking at me like that. You can tell me why. Heather? Because you don't get it. You take the sine. It's important to realize sine of 30 degrees, sine of pi radians, you don't get any dimensions for them out of it. So we have newtons divided by coulombs times meters per second. So let's move it around a little bit here so we can figure out what this actually is. So newtons divided by, we're going to move the seconds over. Rather than meters per second, we're going to have coulombs per second. Duval, what is a coulomb per second? Class, dimensions are your?
Friends.
Friends! Duval, have you not been playing spoons with dimensions lately?
No. Is it a joule?
It is not a joule. Coulombs per second, Danner.
Yes.
Amps, that is the dimensions for current. So newtons divided by amp meters. This is what the magnetic field is in, and we give this a name of Teslas. Tesla. Capital T for Tesla.